Okay, so we're looking at this one example, and we're going to use logarithmic differentiation to solve. And so we're going to take, and it's easiest to take the derivative of natural log versus any other base. And so we're going to take the natural log first of both sides of our equation. And so if we take the natural log of both sides of our equation, we get the natural log of y is equal to the natural log of this x to the fifth times natural log of x all raised to the sixth power. Okay, before we even start taking the derivative, we're going to rewrite that right-hand side using properties of logs to rewrite this as a string of simpler logs. And so one of the rules says if you have a natural log of something raised to that power, we can bring that power down front. So this is the same thing as 6 times the natural log of x to the fifth times the natural log of x. And I still need my natural log of y over here, and I'm going to bring it down. So now I'm going to use the fact that if I have a natural log of a product of two things, I can rewrite that as a sum of two natural logs. And so I have to be careful because I have this 6 out front. And so really that 6 would be distributed to both terms. So, but let's just write it this time. So natural log of x to the fifth plus the natural log, which kind of looks ugly, but it's okay, of the natural log of x. We still have the natural log of y here. Okay, so now again, I'm going to need to, I'm going to use the rule of logs. I have this exponent here of x to the fifth, so I can use my rule to bring this down front. And if it's okay, at the same time when we rewrite this, I'm going to distribute my 6. And so I'm going to bring my natural log of y down is equal to 6 times the power I brought down of 5. So that's going to give me 30 natural log of x plus, now I need to distribute this 6 to the other natural log, which is the natural log of the natural log of x. Okay, so I just did a lot of work just to rewrite this so that when I take the derivative, it's going to be a lot cleaner. And so we're taking the derivative of both sides of our equation. So the derivative of natural log of a function, that's 1 over the function times the derivative of the inside. So this is going to be 1 over y times the derivative of the inside, and that would be dy dt. Oops, I'm so used to saying time, so this is actually terms of x in that last section, dy dx. Equals, so now let's take the derivative of each piece. So when we take the derivative of the 30 natural log of x, well, that's 30 times the derivative of the natural log of x is 1 over x times the derivative of x, which is just 1. So this is where looking at what we had just done with the related rates, don't get confused when to take, not, when to put dx dt, when not to put dx dt. X is just x, a variable, not a function of time. So plus 6. So now I want to take this derivative of the natural log of the natural log. So I actually am really using a chain rule here. And so my outer function is the natural log of the inner. And so taking the derivative of that, that's 1 over what you were taking the natural log of, which is the ln of x, times the derivative of the inside. And so the derivative of the inside this ln of x. Well, derivative of ln of x is 1 over x times the derivative of x, which is 1, so I don't have to write that. Okay, I want dy dx by itself, but because I took the natural log of both sides at the beginning, I have this 1 over y times dy dx. So we can get rid of that y in the denominator on the right-hand side of, or left-hand side of my equation by multiplying both sides of my equation by y. And I'm going to keep what y is as the natural log. As this, sorry, not the natural log, as parentheses x to the 5th natural log of x times raised to the 6th power. So this whole side is times y. So my y's cancel, leaving me with what I want, dy dx. Equals, let's see if we can clean this up. 30 over x plus, this is going to be 6 in the numerator, x, I'm going to put that in front, times the natural log of x, all times y. And y at our original was this. Wait a minute. No, it wasn't. Y at the beginning, I had taken the natural log of both sides. Y at the beginning was x to the 5th natural log of x raised to the 6th. So when I put this y here, I'm just going to write it like that. Let's simplify this a little bit. And maybe I could have done that too as a way of when I started this, but power to power, and this is multiplication in between. So I can basically say this is the same thing as y equals x to the 5th raised to the 6th power times the natural log of x raised to the 6th power. Power to power again, multiply. So this is the same thing as y equals x to the 30th times the natural log of x raised to the 6th. This one instead here, because I'm going to distribute it just to make it look like the other one, I'm going to write y in that form. So that was really x to the 30th and all times the natural log to the 6th power. So we have dy dx equals 30. But notice I have an x in the denominator here times this x to the 30th. So it will simplify to x to the 29th power. And then I have times the natural log of x, and that all raised to the 6th. Plus, so when I distribute it to the second parentheses, I have an x in the numerator, x to the 30th divided by an x. So again, I have an x to the 29th. Oops, and I have a 6 in the numerator too. And then I have one natural log of x in the denominator, but I have 6 of them here. And so that's going to leave me with 5 natural log of x's. It looks like I could factor out a 6x to the 29th power. And they did not do that, but we could if we wanted to. Actually, we could have factored out even more. We can pull out a 6x to the 29th, but we can also pull out a natural log of x to the 5th power, right? So 6 from 30, that goes 5 times. I don't have any more x's because I pulled out the 29, but I pulled out 5 of the natural log of x's. So I'd be left with 1 there. Plus, I basically pulled everything out here, so I'm just left with a 1. That's even more simplified. And then could also help us solve for when that equals to 0. Okay, so either way, but the way that they had it here, you can see is the same thing I had first before I factored it out.